Using a percentage of glycol for the chiller allows the water in the plant to lower its freezing point and, under normal operating conditions, never freezes. Lowering the freezing point means that even if the refrigerant decreases its temperature inside the evaporator, it will not reach the freezing point of water, since due to glycol, the ice appears at an even lower temperature. Why is glycol needed in chili? We are going to explain in detail when the chiller 1 cooler can freeze. The correct flow of water comes from the building in a liquid state, at a temperature of 12 degrees Celsius or 54 degrees Fahrenheit. 2. At the same time, the refrigeration circuit is working correctly, according to the chiller control system. 3. At this moment the correct amount of refrigerant arrives at the evaporator of the chiller. 4. The refrigerant has a quality of 10%, that is, 90% is liquid and 10% is vapor. Let us remember that the quality of a refrigerant is a parameter that relates the quantity in the vapor phase with the total quantity of refrigerant. 5. In this case the refrigerant inside the evaporator is at a temperature of 7 degrees Celsius or 44 degrees Fahrenheit. 6. Assuming the refrigerant is R22, the refrigerant inlet pressure is about 75 psig. 7. As the water coming from the building has a higher temperature than the refrigerant, it begins to give heat to the refrigerant. 8. Since the refrigerant is in two phases simultaneously, vapor and liquid, it can receive heat without changing its temperature. However, the coolant begins to increase in quality. 9. The quality of the refrigerant at the outlet of the evaporator goes from 10% to 100%, because at this final point there is only vapor and all the liquid phase has disappeared. 10. All the values of the installation are normal because both the application and the chiller work normally. 11. Now the cold water supply that goes to the chiller goes down, because some floors of the building are not working. 12. Since there is less water, now the cooling capacity of the chiller must go down. We are going to assume that it takes longer than normal for the machine to adapt to the new thermal load, and even at this moment the capacity of the chiller exceeds the thermal load of the plant. In other words, there is excess cold in the installation. 13. The risk of freezing occurs because the refrigerant pressure in the evaporator decreases due to low steam generation due to lack of water to cool. 14. If the evaporator pressure drops, its temperature also drops. 15. If the pressure drops to, for example, 58 psig, the evaporator is at a temperature below 0 degrees C. 16. If the evaporator is below 0 degrees C, a stream of pure water can freeze, because the freezing point of 0 degrees C water has been reached.
Celsius.
17. If the chilled water plant now works with a mixture of hylic water with the appropriate percentage, the freezing point drops well below 0 degrees Celsius. It is necessary that the water is at low temperatures, but that for no reason should ice formation occur inside the pipes. Now we are looking at an exchanger with scale problems due to poor treatment of the water in the circuit that we should know about the glycol used in chilled water plants. Next we are going to list the main characteristics that we must know. 1. Pure glycol or a mixture of glycol and water has a much lower freezing point than pure water. 2. Glycol-based chillers are best suited to low-temperature outdoor environments or environments. 3. The heat transfer efficiency for a water chiller will be higher than that of a glycol chiller. 4. Automotive glycols are not designed for industrial applications as they can foul the heat exchanger and compromise heat transfer. 5. Do not mix different types or brands of glycol. 6. Mixing glycols can often result in clogged filters or gelation. 7. Due to chemical differences and variations in formula between brands, it is important that you not only use the correct type of glycol, but also the same brand. 8. Not maintaining brand consistency can cause inhibitors in the formula to stop working. This will clog your pipes due to the incompatibility. 9. If you change types or brands, you will need to thoroughly flush the system to remove the current fluid. 10. Glycol has a higher density than water. This will increase pumping power. 11. Glycol increases the temperature of the fluid, and the cooling capacity will be slightly reduced. 12. Glycol, due to its chemical makeup, is corrosive to metal in its uninhibited form, which means it will cause your cooler's internal plumbing to corrode, scale, and rust, sometimes too quickly to be noticed before a problem arises. 13. By using glycol that contains inhibitors, a thin molecular layer will be created, which protects your system but does not affect the efficiency of your installation. 14. Using a low concentration of glycol can cause bacteria to grow or freeze in the pipes, which will damage the internal pipes of your system. 15. Too much glycol can cause the fluid in your unit to become thicker than the internal pump can handle. 16. Concentrations above a certain threshold can even cause the freezing temperature of the liquid to rise. 17. Maintaining the correct process water and glycol mix, along with filtration of dirt out of the system, will prove to be the necessary steps to receive years of service from your chiller.